Hello everyone. So today I will be presenting my project in linear regression. The project that I have chosen is transport demand prediction. So in here, I have used a data set uh, for movie ticket. So there, the data set constitute of ticket booking information from 14 location in Nairobi to to Nairobi, and it originate from the other 14 location and it get terminate in Nairobi. Of main bus terminal is called Orpheus Center. So the journey take around 8 to 9 hours, and before and, to the outskirt of Nairobi in Nairobi. So after that, it takes another 2 to 3 hours to reach Nairobi main bus terminal, that is Orpheus Center. So the journey actually, the total journey that took by the bus is 8 to 9 hours and additional 2 to 3 hours. And depending upon the traffic of the main city. So the data set constitute of following information. This is ride ID, payment method, and this is payment receipt, travel date, and so on. And this is the GitHub link for my project. So the problem that we have to solve here is that we need to predict accurately the ticket that will be sold by movie ticket in future for a particular ride on a particular day. So they can, efficiently plan their ticket solding activity and so on. So let us try to build the model, and for that we'll be importing the important libraries and this drive. I'll be mounting on the drive. So this is the first view of the data. So in the data, that first thing that we see is there is no target variable available here because the data that we have been given is the information of per ticket sold. So we will do not have information of the number of ticket that will be sold for a particular uh, ride directly. So we'll solve this problem later. And I see there is no null variable, and this is the information of data that we'll be using. And now, as we know that there was no target variable available, so to find the target variable, we'll be grouping our data by ride ID. And so this way, you'll have that this particular ride have one ticket sold, and this particular ride has 31 tickets sold in it. Now we'll be merging this data to our original data, and so our target variable now will be uh, added as per the ride ID. So there are certain insignificant column because we do not need the information of per ticket sold. So seat number is insignificant and payment method, payment receipt is insignificant for the model. And we know that all bus will be terminate at a particular location that is in Nairobi. So the travel to information is we can drop it because it will be same for all of the rides. So I'll be making a new variables now, and and it is just a you know initial kind of feature engineering, but we'll be doing extensive feature engineering later. And before that, I'll see our data analysis part. So this is this plot of number of tickets sold. So this so most of the time that customer travel, when the most of the time when a bus leaves, it get around 10 to 12 customer. So here is the these are the particular time on which a ride starts, and we can analyze customer traveling preference based on this chart. So again, we see most of the tickets are sold on in these places, and there are few places where very less number of tickets are sold. So here we can get an idea of the kind of city from where the bus is originating. So we can I mean, we can have a rough idea that, okay, these are the big cities and these are the small cities. So that may be the reason very less number of tickets are sold from here. So this is the car type. The most number of tickets that are sold by movie ticket was for a bus comparing to a shuttle. And this is the capacity of the bus. A shuttle type, you know, can carry 11 number of passenger, and a bus may carry 49 passengers. So moving toward the feature engineering, as we have very less number of column available in the initial data. So I'll not be ending our exploratory data analysis here, because we'll be creating more variable from the information available, and we'll be analyzing those as well. So here is the day of year, month, week, day of month, quarter, and day of week. These are the column that I have created, and here we may also see the trend of customer travel using this information. So the day of year, we can see that customer would like to travel in first 100, most of the time in first 100 days, and then in the last of the year. So there are few around 200 days where customer, preferred less to travel. So here is again the same information that we can see around 5 to 10th or 11th month, customer has a very less number of frequency to traveling frequency. So this is week information. Though customer, travel in first 4 months, but there are few weeks where when customer do not wish to travel. So this information need valid for that. And the month information is the same thing. And this is the quarter information. Here we can see that first and last quarter uh, are the one where customer like to travel the most. So going forward, this is the day of week information. So there is no significant difference in day of week. Uh, I mean, week of day travel preference for the customer, and negligible. There is no such preference that customer would like to travel on weekend or not like to travel on weekday or weekend. So there is no such preference. And going forward, we will create another more variables. So the weekend will be seeing all this information again. So I have created another weekend column. So if the date lies on a weekdays, will be a zero type, a 0 point, and if it is on the weekend, then it will be a one. Then the hour information, the ride originates on which hour of the day and day of week. So this is, and I'll be creating another variable for the period as well. So I'll be considering if someone travel from, you know, 0 100 hour to 500 hours. So I'll be taking it as a late night, and then they travel between 500 hour to 1000 hour. That is 5 a.m. to 10 a.m. So we'll be taking it a morning and so on. So let us see again the distribution of these data. So here we can see if the customer there is a preference for customer travel. So they mostly like to travel between 5 to 10 a.m. And very, there are almost no tickets sold after that. And then there is another peak at around like 7, 6 to 7 p.m. in the evening. And this is the same information. In morning, customer would like to travel the most, and then in the evening, and afternoon and night has very less number of customers. So now we'll be making more features based on the traveling frequency. We'll be assigning higher weight to the to morning and then to the evening, and based on it we'll be making another column that is period weight. Similarly, we'll be making another column as a day of year weight and week of year weight and so on. And we'll be checking distribution for the same. And we see that the morning has the higher weight, and this will help our model to capture, it will help our algorithm to capture the trend to predict the number of tickets sold. And now there is some another feature engineering information. So although these information are not given that what is the distance between Avido and Nairobi, but this information can be easily found, and there is no actual costing involved in it, and because you can find it on the internet. So this may be the important information as per my understanding, that if a customer travel from Avido to Nairobi, so what is the distance covered by the shuttle? So I have captured all the information. So if the bus travel from Avido to Nairobi, so it will be traveling around 352 kilometers, and home bay to Nairobi, it will be 360 and so on. So this way I have mapped my travel distance to Nairobi column information. And now we have already been given. So the travel time to outskirt of Nairobi will be 8 to 9 hours as per the problem statement given to us. So you just I just took a mean of 8 and 9, that will be 510 minutes. So I have made another variable travel time taken to outskirt is 510 minutes. And then it will take another 2 to 3 hours to reach to the Apia center in Nairobi. So again, I have taken mean of 2 to 3 and added to 510 and created another variable total travel time, that is 600. The total travel time now it will be 660 minutes. So these are another variable for my model. So then the another these are the information. If a bus originate at a particular time, so when will be the next bus available for the to the customer? So does customer has any any trend based on that information, or the previous bus when the previous bus was available for that destination? So does the customer has any such trend? So I have taken arrival time to out. No, sorry. Here, arrival time to outskirt, arrival time to Nairobi. Oh, sorry. So I'll be creating that feature in the future. But now this is the time. This is the arrival time to outskirt of Nairobi. So based on the information, when our bus started from the origin, I'll be adding 660 minutes and will calculate the time at which the bus will arrive at the outskirt of Nairobi and to the main bus terminal. So this is the information that are captured here. So now we'll be creating at the variable at arrival time at no traffic rush time. So at here, a heuristic approach I have made that if a customer, if a bus arrive between 8 a.m. to 10:30 a.m. So it will be a rush hour because all of the everyone want to reach to their office. So there will be a lot of traffic in the streets. And similarly, from the 6 p.m. to 8:30 p.m. I have considered them as a rush hour because the same employees would like to reach to their home. So these are the rush hour. So if a bus, arrive at Apia city center at that time, so we'll be considering it as a rush time. So these are the information. So these are the you know rides that actually arrived at a rush hour. So this will be the first look of our data set. Now it will be looking. I'll be using it to predict number of tickets sold. So we'll sort the value of travel from and travel date and date and time. So as I previously explained, so will be when the next bus will be available, when the previous bus was available. So delay between the previous and next bus. So these all information I'll be capturing here. So now I'll be checking null values. So after making this many variables, so I see that there are some certain null values, and I'll be just filling all these null values by using fill and backfill method. So again, I'll be seeing the mean, mode, and median information. 25. These are the description of the data available. So will be checking correlation, multi-correlation. There is some correlation between these mul internal correlation, but this is because all these variable are extracted from a same feature. So this may be present, and but we'll be dropping all those date variable. So 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 for the categorical variable, car type and travel from, we'll be converting them into dummies, and we'll be dropping all these travel date, travel time, because we have captured all this information and the weight. So this will be the number of column that we'll be using for our X feature and Y feature. So the first model that we'll be trying is linear regression. And before applying the model, we'll be scaling the data to max scaler. So we'll be using min max scaler. That is because we will not be having all of the data on a same scale. So min max scaler will be the best, as per my understanding. So here I use the linear regression model, and the accuracy that the first model has given me is the 100%. So this looks pretty good, for the initial attempt. But when I go to see another metrics, that these MSC, RMSE, MAE, and this, so there is some MSE 2.41. Although it is not very bad, but I'll try to improve it in the next model. So I have tried this regularization and used grid search CB to for hyperparameter tuning. And and this lasso model. And and again this MSE, I was not able to turn this MSE to zero in these model, but random forest model has performed considerably better. And after grid, so hyperparameter tuning, I was able to produce a model that predicted this information to 100% with all zero MSE, RMSE, MAE, MAPE. So this model is fit to be used, and I have also tried several other model as well. This may not get any better. So here this model, random forest model, gradient boosting regressor and HG boosting regressor. So I have done hyperparameter tuning and regularization. And as I have already mentioned, that I was able to produce a model that would accurately predict the number of tickets that will be sold by movie ticket with zero MSE. So I at this point of time the model can be model can be used by movie ticket to predict the number of ticket that will be sold on a particular day. And this model can also be used by the travel companies. So if they want to arrange the type of bus or the number of bus. So it can be also useful for that, because if there is a particular day in where we predict that there will be only you know 10 passenger who will be traveling to Nairobi, so they can arrange a shuttle rather than a bus. So the traveling of shuttle might be economically cheaper than a bus for a travel company. So this may be done. So this is all for my project in linear regression about transport demand prediction. Thank you for your time.